Q8031. What is the purpose of the safety circlet installed on some valve stems? A. To hold the valve guide in position. B. To hold the valve spring retaining washer in position. C. To prevent valves from falling into the combustion chamber. The correct answer is C. The safety circlet is a retaining ring installed on some valve stems. If the valve stem tip breaks, the circlet contacts the valve guide and helps prevent the valve from dropping into the combustion chamber. Q8032. Valve overlap is defined as the number of degrees of crankshaft travel. A. During which both valves are off their seats. B. Between the closing of the intake valve and the opening of the exhaust valve. C. During which both valves are on their seats. The correct answer is A. Valve overlap is the number of degrees of crankshaft travel during which both the intake and exhaust valves are off their seats at the same time, near the end of the exhaust stroke and the start of the intake stroke. Q8033. The valve clearance of an engine using hydraulic lifters, when the lifters are completely flat or empty, should not exceed A. 0.00 inch. B. A specified amount above 0. C. A specified amount below 0. The correct answer is B. When the engine is running and the valve lifters are forced up, they are utilized to keep all of the clearance out of the valve system. There will be clearance in the system of a specific amount above 0 when the lifters are totally flat. Q8034. If the exhaust valve of a 4-stroke cycle engine is closed and the intake valve is just closed, the piston is on the A. Intake stroke. B. Power stroke. C. Compression stroke. The correct answer is C. When the piston is rising during the compression stroke, the intake valve closes. The exhaust valve is already closed at this moment. Q8035. Which of the following are factors in establishing the maximum compression ratio limitations of an aircraft engine? A. Design limitations of the engine, the degree of supercharging and spark plug reach. B. Detonation characteristics of the fuel, design limitations of the engine, and spark plug reach. C. Detonation characteristics of the fuel, design limitations of the engine, and the degree of. The correct answer is C. Supercharging. The maximum compression ratio limitations of an aircraft engine are influenced by several factors. Detonation characteristics of the fuel. Different fuels have different resistance to detonation or knocking. The maximum compression ratio must be limited to prevent excessive cylinder pressures that could lead to detonation, which can cause engine damage. Design limitations of the engine. The engine's design and construction materials play a role in determining the maximum compression ratio. Factors such as the strength of the cylinder head, piston design, and overall engine durability need to be considered. Degree of supercharging. Supercharging is a method used to increase the density of the air-fuel mixture entering the engine. The use of superchargers or turbochargers can increase the maximum compression ratio, but it must be within the limits allowed by the other factors mentioned above. These factors need to be carefully evaluated to establish the maximum compression ratio that ensures optimal engine performance while avoiding issues such as detonation or engine damage.